Today I will be demonstrating Opturion's container packing algorithm, specifically the web-based application designed to both contain the data as well as visualize the solution. So a bin packing problem consists of a set of items to be assigned into a set of containers. So up here we can see two separate tabs describing this information. So first of all, if we select containers, we can see that each container here, one row representing a container, consists of an ID. This is a unique identifier for that container. It has a width, a height, and a length, which specifies its maximum volume. There's also a maximum weight constraint that can be enabled, as well as a cost to use this container. If I double click on the container, we can also see that information here in the table, and it also can be edited via this interface. Similarly, items are listed in the Items tab, each row representing one item. Again, items have an ID. Here they have a type, so an item type specifically a cuboid, being a rectangular box, or a cylinder, specifying a cylinder. Cuboids have a width, height, and length, whereas cylinders have a height as well as a diameter. Once again, this specifies their volume. They can have a weight, and the various types of rotation that the items are allowed to undergo can be defined here. So each of these columns specifically represents rotation along a given axis, and these are described in more detail within the documentation. We can see here that some items can be fully rotated, others cannot be rotated at all. You can also set whether the item is heavy. So a heavy item must be placed on the floor of the container and cannot be placed on top of other items. It can also be marked as fragile, where what this means is that an item cannot have if an item is flagged as fragile, it cannot have another item placed on top of it. There's also a profit associated with the packing of each item. So if we go back to the dashboard and we actually click Solve, what happens is in the background, the algorithm that does the plans the packing runs, and once that is finished, we'll actually see some new tabs appear across the top here. There we go. So we have new tabs, the container solutions, the visualizer, and the unassigned items. So we'll first look at the unassigned items, and we can see here that some of the cuboids, 35 to be specific, have not been assigned. If we look at the container solutions, we can see a solution for each container. We've got information around their packed volume, the percentage, so in this case 52% of the volume was utilized, as well as the packed weight, maximum weight, and the weight percentage, which is not really a factor here. And if we click here to expand out this container, we can see the information for each item within the container and its origin coordinates as how it is packed in the container. The more useful here is the visualizer. For each container present in the scenario, you can see here listed down the side, so container 1 and container 2, as well as each item packed within that container. So this representation here is what's called the mesh representation, and it shows each item as a mesh screen. I'll change to the solids representation down here, and we can see how these items have been packed. So here we have some cuboids, some vertical cylinders, as well as some cylinders packed in more of a horizontal configuration. Interesting to note here the difference between the Opturion packing algorithm and some of the other packing algorithms available, in that cylinders themselves are not treated as cuboids or simulated as cuboids. They actually are packed as cylinders. And we can see that particularly here when we view the cylinders packed horizontally, in that they're nested in a pyramid style packing configuration, which takes advantage of the way you can conserve space by nestling them within the grooves in other cylinders. Container 2 has its own packing configuration as well. But if I jump back to container 1 here, and one of the useful things you can visualize here is the actual packing of the container. So these items, you can see as I actually select an item, it's highlighted in red in the visualization. When I click at that item, it will bring the packing back to represent what the container would look like when that item is packed. So for instance, here item 117 is packed in that corner. And as I step through the packing, you can see more and more items being added. If I jump forward a bit, we can actually see where we start to pack these in a more horizontal configuration. And if I zoom in and I change the orientation, you can get a really good view of how this cylindrical nestling works. So that's a brief overview of the Opturion bin packing algorithm and application. If you have further questions, please don't hesitate to reach out, and we'd be happy to organize a more in-depth demo for you to show you some of the other features. Thank you for watching.